Thus far in the course, we've taken a look at the idea of univariate data, and we've been able to find mean, median, mode, standard deviation. We've been able to graph it by using histograms or other categorical types of measures, but we haven't taken a look at associations between data. And what we're going to do in this section, and as well as the next one, is we're going to start taking a look at bivariate data. Now, bivariate data is exactly what it sounds like. Two variables, all right? So whenever you see this term, what we're doing is we're taking a look and we're trying to see if there's any association between two variables, all right? So for instance, education and income. Generally, we know that the higher somebody's education is, the higher their income is, unless they're a teacher. Age and bone density. We know that as age increases, in general, the density of your bones decreases. And then sometimes we just have two variables that we're studying that don't always have some sort of relationship. So for example, the number of bowling balls you own and the number of inches of rain per week. These are two values that are absolutely not associated with one another in any sort of way. They're just completely random. All right. So let's put some definitions together. With the response of, or with the idea of education and income, any data that is directly associated, okay, or you could say directly proportional, means that in general, as one of the variables increases, so does the other. And then we have the idea that as one variable increases, the other one decreases. That's going to be called inversely proportional. And remember, we talked about the idea of age and bone density. As your age increases, your bone density starts to decrease. Age and income would be related to directly proportional. Now, there are two different types of variables, obviously, in bivariate data. And the first one that we're looking at is the variable that basically tells us what is going to be the driver, okay? So that's going to be something called the explanatory variable. Okay, not independent, but the explanatory variable is the variable that is going to use to predict the association. Okay, so a lot of times it's similar to independent, okay, but it's not quite the same thing as an independent variable. All right, they could have some dependence, but in general, we use explanatory variable to describe what's going on. Now, the variable that is acted upon is called the response variable. And the response variable is exactly what it sounds like. It responds to some sort of treatment that's invoked by the explanatory variable. Remember in the very first section, we talked about variables that might actually be the cause of some sort of association. Remember, those are called lurking variables. And especially in statistics, we have to be extremely careful of lurking variables. Okay, so a lurking variable is any variable that is somehow related to the explanatory variable and the response variable. So for instance, education and income, all right? They are truly related by a lot of studies, but there's always the factor of motivation. And generally, people that are motivated are going to get through their degree. And also, there are a lot of people that don't have a college degree, don't have a lot of education, but they're very motivated and they have very high incomes. So we have to be careful of these ideas of lurking variables. They might be the real cause, in other words, the real explanatory variable that's going on behind an association. One of the best ways that we can look at kind of graphing what one of these types of relationships looks like is called a scatter plot. A scatter plot is going to be a graph that shows a relationship between two variables. There's three types of characteristics that we're going to be looking for. First of all, we're going to be looking at the strength. Okay, so is it strong? Is it moderate? Is it weak? All right. Basically, the closer that the data is to forming some sort of perfect curve, whether it be a line or an exponential relationship or whatever it might be, that means you're going to have a stronger association between the two variables. direction is either positive or negative. And remember, we talked about the idea of directly proportional and inversely proportional. If the variables are directly proportional, we have a positive relationship. And if they're inversely proportional, we have a negative relationship, or a positive and negative direction. All right. The type of association. So the type of association basically talks about the shape. All right. So it might be a line. It might be like a quadratic sort of shape. It could be exponential. It could be sinusoidal. All right. There's lots of different types of associations. In our class, the only one that we're really interested in are linear associations, the ones that have straight lines. Okay. So whenever you draw a scatter plot, one of the first things that you want to do is determine if it's linear. All right. If it is linear, then you probably want to keep going and doing the investigation, at least in our class. If it's nonlinear, then at least in our class, we're not going to be studying it too much. All right. So in the next video, what I'm going to do is I'm going to help you to construct a scatter plot. We're going to analyze that scatter plot by identifying the strength, direction, and association. And then we're also going to talk about what the scatter plot really tells us about the two variables.